Hello, everyone. Welcome to this pre-release webinar for the InSite new version 3.15. My name is Junlei. I'm the Senior Geophysical Consultant with Itasca UK. I'm also managing this software. So first of all, a few housekeeping details. So this webinar is being recorded and we'll make the video available at the end of the webinar, either by our YouTube channel or on our main web page. So the video will be available afterwards. And this webinar is the pre-release for the software in the InSite product family 3.15. So that including HF, Geo, and Lab. After the final release, you can log on to your web portal and you should be able to see which functions are specifically available for your product, either InSite HF, InSite Geo, or InSite Lab. The official release, we're targeting next January 2019. Given that said, that doesn't mean all these new functions, you won't be able to access them before that. So at the end of the webinar, I'll talk about how to get a beta release before the final release. In this presentation, I'll combine live demonstration with some figures from PowerPoint slides. I recognize the live demonstration is a little bit time consuming, so depending on how many time we have, we'll do some live demonstration either during the way or at the end if you're interested in some special functions. At the end of the webinar, we'll have a QA session. So if you want to join the discussion or you have some questions, that's the time for the group discussion. Um, but do remember the webinar is being recorded, so if you want to stay anonymous, you can text me the question using the text box. I think it's at the right hand side at the bottom. You have a chat, so you can send me your questions during the webinar or in the QA session. But if you want to ask the question orally, you can raise your hand. I think there is a button to raise your hand, and I can unmute you for the discussion. So what's new in this new version? First of all, a few good news for the active subscribers. The annual maintenance and support plan. Well, actually, it's called AMP before, but actually, for those who are under this plan, you're not only getting the maintenance, you also get a fair amount of support, technical support. So we bring the word support back into the name. The acronym now we call that AMSP. So if you're active subscribers, here are the good news for you. As before, you will continue receive free upgrade. So the annual release, the functions major new development that's not available a year ago, you'll have that for free, and also bug fix updates, feature enhancement during the year. So depending on how many bug fixing we made and feature enhancement we did, we'll release those updates free of charge to you. So we'll also add some free webinars. It's not going to be a long webinars like an hour like this one. It's going to be 10 minutes, 20 minutes short videos. And in those videos, we're going to share our experience of microseismic data application in different field. So for beginners, you may want to tune in the webinars like the benefits on microseismic monitoring. We're going to share with you a simple workflow, how you can use InSite to quickly receive the catalog, start from the raw data to a catalog data. For advanced users, you may want to tune in microseismic geomechanics. So in those videos, we'll share with you how you can calibrate a geomechanics model with your microseismic catalog. So that's for advanced interpretation of microseismic data. I know some of you are out there are not processing microseismic data for commercial purpose. You're actually doing that as a QC, your quality control other people's processing results, your vendors or different contractors' results. As a regulator, you may want to do a QC step. So we're going to share with you some tips and experience, the workflow, how to do a quality control using InSite. For lab users, we'll share the acoustic emission case studies that we collaborated with other lab users, and you may want to join this collaboration if you want. So those are the free webinars that we are planning for next year. If you don't have time for 10 minutes, 20 minutes video, we're going to share with you in the newsletter. So we call that InSite Bites. In this newsletter, we're going to share pretty much the same thing, some tips, some experience that we use to use InSite to just to boost up your productivity when you're using software InSite. For example, if you can actually in the move out view, you can draw a line, and then InSite will automatically pick the first arrivals based on that line. If you don't know what I'm talking about, that's actually the reason you should tune into the newsletter. We'll share more tips like that in next year. So what's new in this new version 3.15? The details, as I said, will be made available in your web portal. So if you go to our web page, log in, and there will be multiple sections describing specific functions that's available in your product, including new processing functions, new data format that we support, new events triggering, different visualization techniques, splash window, and all bugs that we fixed in the previous year. In this webinar, I'm only going to cover some of the highlights. So that will include the uncertainty analysis. It's a new tools to analyze the location uncertainty and also visualize the data, export the uncertainty for additional processing if you want. A super stage function, we call that a super stage, is basically stacking multiple stages. So not only you can stack waveform, right, to boost up the signal to noise ratio, now you can stack multiple stage to enhance or enrich your catalog. Source scan is a tools that allow you to locate events without picking the first arrival. And also modified AIC. So it's a different way to do the first arrival. The source scan also use the modified AIC trace for signal detection. In terms of the data format, we now support
Businesses. That's Lizzie Clark's time in London saying.
sorry, I think I didn't know. Sorry about that. So we now support a new data format, the DTA format. So that's for the lab acoustic emission. If you have, for example, physical acoustic companies, a hardware for data acquisition, you may encounter this data format, DTA. And now InSite directly can import a DTA format. Some other acquisition system may use a TXT format. So if you're using that AE system, InSite directly support that. And as always, we are looking for new binary format that if you have a binary data format and you want InSite to support that, tell us the data structure and we'll add that to InSite free of charge. Events triggering, that's a new function called matched filter. So some of you may be familiar with that term. It's basically using a template and use that template to cross-correlate your data stream and look for similar patterns. So it's very selective and very sensitive to weak signals. There's some new functions that I'll show in visualization. Splash window, it's just a tiny function that we changed. Each time now you open InSite, the splash window will tell you which version you're opening. So you can have multiple versions installed in your single computer. So you will know at the very beginning which version you're opening and some bug fixings last year. So the first function that I want to demonstrate is this uncertainty analysis. The figure on the left is the existing visualization that InSite had, and on the right are the new visualization and uncertainty analysis tools. In the past, what you are seeing here are a ellipsoid. The axis of this ellipsoid corresponding to um, the travel time residual as well as the angular residual. In this specific example, you're looking at a single borehole. So this longest axis corresponding to the angular residual. One of the critics that we received in the past is imagine you have 1,000 geophones and now you downgrade that 1,000 to 10. The residuals will be reduced by that because you can fit your model better because you have less observation. So, but that doesn't mean your uncertainty is reduced. To address this problem, we are introducing this new uncertainty analysis tool. It's not going to completely based on the residual. It's based on so-called the Bayesian network. You specify a priori uncertainty that you're confident in your data first, and InSite will tell you what's the confidence that you have in terms of the location. So all this are isosurface. So it will tells you, well, within 60% confidence your location is within this range, or 90% of confidence your location is within this range, given you are confident in your data. So here is the interface that we have. The bottom part is to specify the uncertainty parameters. So I have 1% of uncertainty in my velocity for both P and shear wave. I have 1 millisecond uncertainty in my first time arrival, and I have 5-degree uncertainty in my angular residuals. So you can, based on the residue, to estimate this uncertainty, or you can have your own um, perceptions in terms of the uncertainty. And that's just a standard deviation. So for example, if your layer has 5,000 meters, then 1% of that is 50, 3 times of the standard deviation. That will give you plus minus 250 meters per second. And that's really a relatively large range in terms of the velocity uncertainty. So let me switch to the live demonstration, and I hope you can see this interface. Okay, so as you can see here in this example, I have a single borehole observation. This is just showing you the velocity, and I have about 60 events that I calculated uncertain. So a typical operation is, for any events, you may want to look at a specific events to fine tune your parameters here before you do a batch processing. Right, so in this example, I just specify my velocity uncertainty is 1%, my arrival uncertainty is 0.1 milliseconds because it's in the borehole. So the sampling rate are usually high, and I can specify 10-degree uh, angular uncertainty. So that depends on the signal to noise ratio. Good quality data usually have less uncertainty, and I want to have 68%. 68% confidence level corresponding to 1 times the standard deviation of the Gaussian. Right, so 60% confidence level will plot the one standard deviation away from the mean. And I do the recalculation, and then the right-hand side events has been updated using the new parameters here. Now, if I want to increase my confidence level, say I just want about 90% confidence level. So that's corresponding to 2 times standard deviation away. And I don't need to do the recalculation. It's already in the memory. I just click OK. And as expected, this shape will grow. Given your uncertainty in your data, that's the confidence that we have in terms of the location. So 90% of the time, the events will be within this range. This shape is not necessarily a ellipsoid, as you can see here. I have another example here. This shape corresponding to the velocity models you're using. So if you're using a different velocity model, the shape will look different. So once you're fine with these parameters, and then you can do a batch processing in the alter processor, and all events that you visible in the 3D visualizer will be calculated. The range, the uncertainty range, north, east, and down, will be saved in the PCL file. So if you want to output that, you won't be output the exact shape, but you can output the box that best fit this shape. And you can output that as your uncertainty analysis for additional processing. So that's the uncertainty analysis function. The next one is the super stage. So as I said at the very beginning, if you have multiple stages, you can stack them as a single stage to enrich the catalog. The reason we want to do that is multiple stages that are close to each other, usually the injection episode is repetitive. So that means the injection pressure and the slurry rate is actually changing the same way. It's kind of a repetitive, it's just a different location. If that's the case, you can actually stack them together. One of the reasons that we want to stack multiple stage closing location to form a super stage is sometimes one stage doesn't get enough microseismic data. So if you have one stage get a 100 events, another stage close to it may have 20. So if that's the case, you won't be able to do much statistical analysis based on that 20 events for that stage. And one of the solution that we provide is now you can stack those multiple stages, 2 stages, 5 stages, depending on how repetitive your injection schedule is. So you can stack those multiple stages and you form a super stage. So the left are 2 stages, the right is the super stage. So all the events are stacked together, so they're merged as a single stage. Same for the engineered data, the slurry rate, the injection pressure, as well as the locations, which are the dots here, are merged. So basically, it's taking the average. And now we have the injection schedule for this super stage, and you enriched, so it kind of doubled the number of events in that stage. So you have more events that you can correlate that response with your injection schedule. So you can now correlate how I inject the pressure will increase the microseismic events, how they grow in terms of the fracture network. So that's the basic idea of this super stage function. Let me see if I can demonstrate some of the operations here. So here is the PCF file I have. And we see 2 stages basically. The stage 2, the stage 3, each one roughly 200 events. So if I can make a super stage, I'll get 500 events a stage. So to do that, I need to go to the frag manager. So this is only available in InSite HF. And I need to specify the time for each stage. So I have these 2 stages here, stage 2 and stage 3, and you have to specify the starting time of that stage. So that comes from your the field crew notebook. So that's for stage 2. You also specify the the stage property for stage 3. So the time has to be specified. Otherwise, the software doesn't know how to stack the events as well as the engineered data. So once you've done that, and you can also import the treatment data for that injection well. So that's a new interface here. Just quickly show you, which is this interface. So once you import that CSV file, now you're going to have all the engineered data that's imported into the software. And I decided to display only the total slurry rate, treating pressure, the slurry rate, and the downward coordinate. Click OK. Then stage 2, because you specify the time, the treatment data becomes available. So you can select and see the pressure data for stage 2. You can also display the pressure data for stage 3. For these 2 stages, it's for demonstration purpose, so the events are not necessarily corresponding to, it's not from a real project. But the episode is kind of repetitive, as you can see, the injection pressure as well as the slurry rate. So now I want to stack these 2 stages as a super stage. Let me close that. And I say create a super stage. And then it will be available how many stages you want to stack them. So in this case, I only have 2, so I only see 2, and I create a super stage. So that's the default super stage. Will tells you which stages are combined in this. Stage 2 and stage 3. It will tells you the stage starting time for each stage and also the treatment data. Now it's being stacked. So this the magenta color is the slurry rate. The blue is the treating pressure. So that's the average across these 2 stages. And those events are the stacking of these 2 stages. So it's basically shifting them to the centroid of the 2 stages. So that's the basic operation when you want to create a super stage. The idea for that, as I said, is just to enrich your catalog for a better a robust statistic analysis to correlate your microseismic data with geomechanics. Now, the third function that I want to highlight in this webinar is the source scan function. It allows you to locate events without picking the first arrivals. Um, there's many techniques. The implementation are slightly different. Some stack the short time, long time window. InSite stack the modified AIC, the archaic information criteria, the AIC criteria. So the idea of the AIC is to look for statistic patterns that are different in terms of noise and the statistic patterns in the signal. So in cases that you don't see a nice signal like this, as long as the statistic properties for noise is different from the signal, the AIC will show you something. And that gives us the hope. If the signal to noise ratio is really low, and the AIC can detect some of the P wave and detect some of the shear wave, using source scan can give you some hope to locate event without the user picking the first arrivals. So the example here I show you is actually a really good signal. You have P wave and shear wave without picking the first arrival. The InSite will locate events and then show up the theoretical arrivals. And that's kind of a quality control step to make sure that the source scan did locate the events well. The problem with that is the source scanning is to check every single point in space and stack the energy following the theoretical travel time and pinpoint that point that is the maximum of the energy, the stacked energy. In that error space, if you can imagine a 3D space, it's very bumpy. It's not like the travel time based error space. It's smooth, it has a unique global minimum. For the source scan, because you're stacking the waveform, so you're going to have multiple local minima. And because of that, the source scan sometimes may not pick the global minima. Instead, it will pick the local minimum. But even that, it still will matches the waveform. So the travel time will matches with your waveform, but the location may have some deviation away because we don't have the azimuth constraint are not as good as the travel time. If that's the case, you may want to follow up with the traditional collapse grid search using the theoretical arrival time. So that's built in the source scan techniques. So before I do a demonstration, I just want to quickly show you how we do this global search in the 3D domain. I use the example of 2D. The error space is showed in this color. So the red are global maximum, which is at the center. But in addition to this global maximum, you also have many local maximums. They're not the maximum value, but it's a local maximum. The source scan is to scan this 3D surface, a 3D volume, northeast down, as well as original time, and look for this global maximum. You need to specify the number of particles. So we're using this particle swarm optimization. In this example, there's only 50 particles. So it's like a flock of birds looking for food. So you throw them randomly into this 3D space, and they will start to look for the global maximums. So in the first few iterations, as you can see, some of them found a local minimum, a maximum, and they will tell the rest, oh, I found a food, come over. And during the time, the bird are still searching, and one of the bird found there is a maximum that's better than the previous found. So the global minimum can be detected in the very early iterations. You don't have to wait till converge. In a very few iterations, they will be able to detect the global maximum. And of course, the other birds are not settled. They're still searching within the space in the hope that they will find a better ones. But in this case, they already found the global maximum. So if you want to continue the iteration, you can, but that's no point. You just output the maximum. So after a few more iterations, all birds, 50 particles, all agree that's the global maximum. So that's the theoretical background for this source scan. Um, Oops, let me switch to the examples using this source scan. Um, so the case, well, I first show you the acquisition geometry. So I have the borehole here. This I think is a gamma log, and I have the monitoring borehole, which is at the vertical part. The treatment borehole is this blue well path here. And the example I'm showing you are the synthetic data, not allowed to show you the real data. So I'm generating some synthetic data from a anisotropic velocity model. And what we are doing is we add um, some noise in it. So this is artificial noise and this is synthetic waveform, and I know its location. The first step is to go to the locator and make sure you are selecting source scan as your location method. Um, source scan only support the travel time grid method, so you have to generate a lookup time table first, because the computation time, the computation amount is really huge. So using the lookup table can save some of the computation time and also make sure you enabled the parallel processing. The next step is to import the travel time table. I need to find my travel time table. There we go. So this is a vertical VTI travel time table, but we are only using the P wave and the early shear wave arrivals. So now we have the travel time table in it. All I need to do is just locate. Oh, let me show you the interface. So here on the right hand side is the new source scan algorithm interface. You need to specify because the source scan is searching the AIC trace. So you need to specify a time window, and that time window, you can estimate that time window, go to the channel view and look at the characteristic function. So that's 20 sample size for P wave and 20 sample size for shear wave. The CCR repeak, because after you locate the events, you have a theoretical arrival. So CCR repeak is to make sure, do I need to fine tune my first arrival a little bit to make sure my peaking arrival close matches my waveform? You can add that if your signal to noise quality is not very good. The number of iterations, as I said, you don't need to wait it to converge. So 5 iteration, 10 iteration is good enough. Maximum particles, in this 2D example, I only use 50, that's enough. But in the 3D or 4D dimension, you may use much more particles than that. So I use 20,000 particles. And this is a parallel processing, so 20,000 is still within the relative time, reasonable time. You can follow up with a source scan into grid search, and then the InSite will search within
Oh,
surrounding
yes, it
the
is.
theoretical location and search within that range. If you don't want to do that, you can just uncheck that.
Yeah.
So click OK here. That's everything I need to do, I think. Make sure I'm using AIC method. Yes. Okay. So 10 iterations. It takes about, so this is a nice little features we add. Now you can estimate the time. It takes about 1.7 seconds. If I close that, you're going to see the first arrival and the shear wave arrival as well. You should pick up the both P and S wave. If you look at the locations here, so it's actually very close to what it's supposed to be. And I know because of synthetic events, so I know its locations. So it's it's a very reasonable. Someone may argue that, well, in this case, I don't need a source scan. I just use automatic picking, and then I can just locate events as well. Yes, you can do that. But in a situation like this, it's kind of hopeless. So the source scan will give you some hope in a case like this. The signal to noise ratio, there's no way you can pick the P wave, and you do recognize there's some shear wave arrivals here. But you're not sure. So in this case, you can use the source scan as a guidance to pick the first arrivals. So you can still run. source scan, and it will pick something that's coherent in your data, and also consistent with the AIC signals. So source can think this is the P wave somehow, and this is the shear wave. So you can do a quality control. You go back to the events and you look at it's located right there, and that's events 2. That's actually what is supposed to go here. So if you look at the plan view, you can see there's some angular residuals here, and that's because InSite relies on the P wave to calculate the source vector, and because of the low signal to noise ratio, even you can pick the first arrival for P, you are still have the same problem. So it's not a issue from source gain, it's an issue from your signal to noise ratio. So the point of that source gain is it gives you some hope when the signal to noise ratio is really low, and you do want to be able to locate every single triggered events as much as possible because your stage doesn't have enough microseismic events. So that can give you another tool to enrich your catalog in addition to the stage stacking. So that's um, the functions in terms of the source scan. The next one is the matched filter triggering or matched filter retriggering, depending on if you have a template already before you trigger the data or you don't. So if you don't have the template, um, the match filter, the idea of match filter is use a strong signal and use that as a template to cross correlate with your data stream and look for signals that matches the same pattern. So that's the idea behind the matched filtering. Now, InSite can do that, and the figure I showed you here are one of the results. This is the template I'm using, and I was able to detect weak signals and weaker signals. As you can see, they have the same pattern, but the signal to noise ratio are much, much weaker. So you can argue that using the short time or long time window, the function InSite already have, you can be able to trigger events like this for sure. The problem is when you lower or increase the sensitivity of your triggering parameters, you will detect weak signals like this. You will also detect lots of false triggers. So you will detect lots of noise in order to get weak signals like this. Using a match filter, you're very targeted, very selective, and you will be able to get weak signals like this. So that's the output using a matched filter. So if you don't have the template, you can first go over your data, make your detection triggering method very less sensitive. So you're only looking for strong signals. And once you get the strong signals, you can select some of them as a template and re-trigger your data stream in order to get those weaker signals, the repetitive earthquakes. So here is the interface for this new function. The trigger method, now you can choose use matched filter. And once you select match the filter, there's a button available at the bottom. You can select template. So maybe it's better to show you using the interface here. So go to the triggering interface. Then in the drop-down menu, you'll be able to see these new functions. Use matched filter. And when you click that, the templates button at the bottom here becomes available, and you can click template. And in this template, you can choose which component you want to use. Where is your template? You can say, I have a template called a component called templates. And in that templates, I have about 100 events. So some of them are repetitive because even strong signal, they are repeating themselves as well. So if you want to just select one event as your template, then you can just select event 11 as your template, and you go back to your raw data and you trigger it again. Or you can just group them together. All the events, you group them together and you say, I want to use all of them as my templates. So in this case, I have 100 templates. So the more templates, the higher chance you'll get detect weaker signals, but it will also increase the computation time. So you may want to balance a little bit. Do I want to have all the events so I can trigger as much signals as possible with different shape, or you want to also at the same time minimize the computation time. So it's all depends on your application. And also, one tips that I want to share is be selective when you select the template. So you don't want to select the template that looks very similar to each other. You want to select a template that covers different shape, and then you use that template, group them in a single component, and you go back to your data and retrigger again. So it's a very good tools to detect weaker signal and repetitive signals for applications like double difference location, double difference tomography, and many other techniques that some of our users are actually processing in their application. So that's the match filter. Match filter takes a bit more longer time because it takes the triggering part. So I'm not going to show the live demonstration. If you're interested in, we can actually uh, organize some go-to meetings with you, and I can show you some of the applications in more details. The visualization. So we have some new additional visualization tools. For example, I can display the fault plane in terms of ellipsis. This is an old function though, it's already in InSite. The longest axis shows the rake of that faults. The additional feature is now you can switch between fault plane 1 and fault plane 2 for major double couple events. There's no way to distinguish the fault plane from the auxiliary pole. So in sometimes you may want to switch between this plane and see if they are actually in line with the neighbor's fault plane, with the non-double couple fault planes. If that's the case, you may want to flip that plane. So that gives you a tool to manually flip um, the fault planes. The other tools that features we add is this lookup table volume. Now you can visualize the lookup table volume. It's in this golden lines here. The golden box is the lookup table. It doesn't have to be in the same volume as your grid search box, which is the black one. So if you're using a lookup table, that's the area that you're searching. But if you're using a file velocity, then the black box is where you are searching. So some convenience features for user to use different functions. The new data format. So as I mentioned, the DTA and TXT, they are for lab acoustic emission data format. InSite already support a lots of format already, as you can see in this two figures here. Triggering, we support a lots of different format. For direct importing, we support even more formats here. So if you have your binary format and you want InSite to support them, just tell us the data structure, we'll add them for you. In addition to that, we also have this third-party catalog. It's a function already in 3.15, 14. Just want to highlight here is you can have a third-party catalog. Uh, the parameters in it can be slip, opening, strike, moment tensor, location, everything. You can import them into InSite and just need to match uh, the third-party variables with InSite variable. And InSite can import the moment tensor, do the moment tensor decomposition, and you can visualize them in terms of beach law, fault plane, or the ellipsis. So it gives you a tools to interpret third-party processed data. So that's kind of a quality control tools that are useful. So that's our goal here is we want to make InSite as diverse as possible, as showed by this icon on the upper right corner. Um, InSite should be independent from the hardware. So it well actually I should are vendor agnostic. We don't believe you have to purchase every service from a single vendor. You should have your own control on every single process in terms of microseismic data processing. Um, so this new data format as well, third-party catalog, is to provide you such a tools to take the control of your own data. So as I said at the very beginning, all these new exciting functions are available in the final release, which it will be next year, 2019, hopefully in the January. But if you do want to have the access to this beta release, we're going to make a data release available this year. And we do ask, we only have two qualifications if you want to use the beta release this year. You need to be active subscribers next year, 2019. And also you're willing to spend less than no more than 30 minutes with us to share your experience in using the beta release. It doesn't have to be a very long. It can be a 10-minute survey, 20 minutes go-to-meeting discussions, and the features we're interested in are, did you find any bugs, any missing features, what's your general experience, and do you have any suggestions? So it's a really good chance for you to participate in the software development and shape the product roadmap moving forward. And we'll continue developing the software with your experience. So the general features can be as small as I want a button shifted to the right, or as big as I want an artificial intelligent agent to help me pick the first arrivals. Can you do that? So varies a lot. So really, we would like to hear your successful experience in using InSite as well as not so successful experience in using InSite, and we'll help you um, make the product better moving forward. So if you're interested, either send an email to myself, which is at the very beginning of this slides, or you can send an email to support@itasca.co.uk. Just express your interest to become a beta tester, and we'll organize something for you. All right, so that's pretty much I want to cover in this pre-release webinar. We have some time for question and answer. If you have any questions, you can use the text box or you can raise your hand and I can unmute you. So we'll give people a couple of minutes to type in questions.
Hi, Joey. I thought maybe
Yes,
I
hey.
could get the discussion started a bit. You were using the modified AIC. Do you have an example of what that actually sort of looks like with the waveforms? You know, how's that? Uh,
Sure, yeah, that's a good question. Well, let's just use this as example. This is the hope list data. And we can actually go to the channel view and we'll be able to see the characteristic function. This is the AIC and here is the modified AIC function. So it's nothing sophisticated here. It's just a time window. Go through the AIC to modify and take the maximum, then subtract the maximum from this time window. You're actually getting this. So it kind of shows you there's some P wave signals here. Don't know, it's kind of debatable for this channel, but for shear wave, it actually has a stronger signals in terms of the shear wave. So yeah, that's what the AIC and the modified AIC looks like.
Brilliant. Thanks, Joey.
Yeah, no problem. All right. Yes, I got a question. So the subscribers are the AMSP subscribers. So those who are staying in this and paying for this annual fee, which is the maintenance and support, you are the active subscribers. Um, But yeah, I do need to clarify that the InSite is a perpetual license. You don't have to subscribe, but if you do, those free stuff is beta test for refer to plan only. Right. So also for the beta tester, if you want to get the kind of a backstage view of the software development, you need to be active AMSP subscribers for next year. So as long as you are active January, February, March 2019, you are qualified for this because we are releasing that function anyhow next year. All right, another question I have here. So what's the exact time to release 3.15? The exact time is January. Which date? Maybe the close to the end of January 2019. We'll have the final release that's available on your web portal. So we'll send an announcement when it's available, and you can log on to the web page and download those functions. So yeah, for the final release, it's next year, January. All right, no problem. All right, I don't see any questions coming in. Right, so thanks everyone for attending. Oh, that's the trick to get questions, pretending I'm going to end the webinar. Do you provide any training courses in the use of the software? Yes, we do have training courses um, every year. So we have two training courses that come in next year. They're actually based online. Um, So if you want to, I think the early bird registration is still active right now. So you can check our webpage on the training sections. There will be two general trainings targeting different time zone. One is more of European and the other one is Asia Pacific. So if you are interested in any one of them, you're welcome to register. So that's paid training courses. If you are active subscriber, again, AMSP or even the premium service plan subscriber, you can have a discount for those two trainings. So that's the full trainings. If you're talking about the free trainings, that's basically the free webinars that I was referring to in the early part of the slides. So there will be like 10 minutes, 20 minutes, either live webinars or recorded videos that we share, and also some tips that we use software, and we share there in terms of newsletters. So yes, we do provide trainings. It can, and right, no problem. All right. Right, yeah, I think it's okay. So what's the difference between InSite HF and InSite Geo? The major differences between these two products is the real-time module. So for oil service companies, for example, you have a field crews, you have trucks, to go to the field, acquire data. You need a real-time module that allows you to uh, fine-tune the parameters in the real time, velocity calibration, geophone orientation. You're going to change your velocity. You're going to change your auto peaking parameters. So all these things happening in the real time. And for different stage, you may have a different velocity, different processing parameters. So to change all that for different stages, you will need a real-time module, and we call that Frag Manager. So that's the major functions that InSite HF have. InSite HF also have many other functions that InSite Geo doesn't have. InSite Geo doesn't have this Frag Manager functions. So we are assuming you are doing most of the time the post acquisition processing. You're sitting in the office, either quality control other people's data or some other application. But it has all the functions that you need for uh, the, the typical seismology data processing. So the major difference I would say is the frag manager you don't have in InSite Geo. All right. All right, so I think we are hitting the mark of the hour here. So I want to thank everyone attending this webinar. If you do want to be part of the beta testing, send us an email and we'll organize things for you. So all the best.